Alright, right now we're going to cover an accounting type problem. It's going to be using polynomials and stuff because that's what we're learning about is polynomials. It's a longer problem and it's got a lot going on, but all of the actual calculations and stuff that we're going to be doing, we're going to be using Desmos again, which is going to make calculations a lot easier. And like the actual math, I think, is easy, but sort of understanding how to build everything might be a little confusing and jumbling. So I'm going to try and break it down as simple as possible. Here we go. The question reads, Jenny has decided to open a savings account that will earn an annual interest rate of R, so that at the end of each year, the balance in the account is multiplied by a growth factor of X equals 1 plus R. Jenny deposits $200 to start the account. She then deposits $250 at the end of the first year and another $400 at the end of the second year. Jenny is going to withdraw all the money after 5 years to use as a down payment on a new car. Number 1, write an expression for the amount of money in terms of X Jenny will have in the account after 5 years. 2, how much money will Jenny have if she has an interest rate of 3%? Number 3, what interest rate does Jenny need if she wants to save $1,100 in 5 years? So the very first paragraph here is just describing what happens, specifically using this word growth factor. And this little X means that each year, so it even says here, each year we're multiplied by the growth factor X. So that means that each year the money is in the account, we're going to multiply by another X. And this statement's going to help us build the actual expression for number 1. That information is going to help us with number 1. It also helps us too that they tell us X equals 1 plus R. So X is going to be 1 plus the interest rate, which is also going to help us solve these number 2 and 3 when they're talking about money and interest rates. And then this second paragraph here, all this information does is it tells us how much money's in her account and how we're going to build that into an expression for number 1. So the first thing I want to talk about is we're building this expression and we're using X is the interest rate, 1 plus the interest rate. So that means that Y is going to represent our money. So if we're looking at a specific point, our points are always X comma Y. So X is going to be 1 point, and then the interest rate, which is a percentage, will be turned into a decimal and it will go at the end of that 1 or be added to 1. And then our Y value is going to be money. That's what Y represents in this case is going to be the amount of money in Jenny's account, and X is going to be 1 plus the interest rate. So we want to keep that in mind when we're going to solve number 2 and 3. But right now, we want to solve number 1. So I'm going to move the problem over here. Try and give us some space to work. Because we need to make a table for Jenny's account. And so in fact, for these types of problems, our table is going to have the number of rows for the number of years that the money is in the account. So it tells us that Jenny is going to leave her money in the account for 5 years. After 5 years, she's removing the money for a down payment on a new car. So that means we need to have 5 rows. And we're just going to work through this paragraph as it talks about the money. So all the money's staying in the account for the 5 years until the very end. So we don't have to worry about withdrawals. And the first thing is the $200 to start the account. So $200 is going to be in there for the first year. So that's 200x, and we could say to the first because it's been in the bank account for 1 year. And what's going to happen is we're going to multiply by an x for each year that the account is open. That's in this top paragraph. It says, so that at the end of each year, the balance in the account is multiplied by a growth factor of x. So every year, we're going to multiply by another x. The next time it mentions money, it's at the end of the first year. So I don't have to worry about this $200. I can just keep going with this $200 for the full 5 years. So in the second year, this $200 that was in the first year needs to be multiplied by another x. So x to the first times x to the first is x to the second. And then we're going to keep going for the third year. This $200, this 200x squared is going to get multiplied by another x. X squared times x is x cubed. And we're going to keep this going, multiplying by x each year till we reach the 5th year. So for the 4th year, 200x cubed needs to be multiplied by another x to get to the 4th year. So that's 200x to the 4th. And now to get to the 5th year, we take that 200x to the 4th and multiply it by another x, which gives us 200x to the 5th. And so that takes care of the $200. Now the next sentence says she then deposits $250 at the end of the first year. If that $250 is deposited at the end of the first year, the $250 experiences its first year in the account during the second year of the account. So $250 experiences 1 year during Jenny's second year the account is open. Because that money was deposited at the end of the first year, we can't put it in there for the first year because it wasn't in the bank account for the full first year. It was only there for the very end of it. And so now this $250 is going to grow every year, increasing by 1 in its exponent until it reaches the end of the account. So 250x to the first, then 250x squared, then 250x cubed, then 250x to the 4th to finish off the 5 years. Oh boy, this is going to be real close. Probably should have gave myself a little bit more room, but we'll make it work. So now, the last amount of money that I need to deal with says, and another $400 at the end of the second year. So, it's at the end of the second year, which means it's not in the bank account for the full second year, and it can't be there for the first year anymore, because it was deposited at the end of the second year. So that $400 has to start in the third year. That's the first year that $400 is in the bank for a full year. So it's 1 year in year 3, then its second year will be in year 4, and then year 5 marks its third year in the bank. So again, those X's keep getting multiplied for each year that $400 is in the bank. So 400x to the first for its first year, 400x squared for its second year, 400x cubed for its third year. And now these 3 pieces, this piece, this piece, and this piece, all reflect for that amount of money. But we want the total amount of money in Jenny's account. So our answer to number 1 is going to actually be the total of all 3 of these things. And if you're wondering how we use the word total, we want to add. So we're adding all of these things up to create the expression for Jenny's account. So there it is, 200x to the fifth plus 250x to the fourth plus 400x cubed is our answer for number 1, the amount of money in Jenny's account. And actually, I'm gonna, let's do, what should we call this function? We're gonna call it j of x maybe? J of x is equal to 200x to the fifth, 250x to the fourth, plus 400x cubed. So the amount of money in Jenny's account in terms of x is that expression. There we have it. Question 2 asks how much money will Jenny have if she has an interest rate of 3%. Now for number 2, we got to keep in mind from up previously up here that our x values are our interest rate. So this is going to be some kind of x value when we're talking about solving this problem. So I've got this equation, and now x is equal to 1 plus r. And in this case, r is my interest rate of 3%. So x is equal to 1 plus 3%, which 3% as a decimal is 0.03. 1 plus 0.03, which tells me x is equal to 1.03. So what we're going to use is we're going to use this x value along with this polynomial to find the y value, which is the amount of money in the account. The y is going to be that dollar amount with the interest rate, because the question reads how much money, they want to know how much money Jenny has if she has that interest rate. So we're going to put all of this stuff into Desmos. We're going to put this polynomial along with this x value into Desmos, and that intersection is going to give me a y value that will be my answer to this question. So here we go. We're going to switch over to Desmos right now, and my polynomial was 200x to the fifth plus 250x to the fourth plus 400x cubed, and then my x value was x equals 1.03. I'm going to change these things. I want this to be purple maybe? There we go, to clear it up from the black and the white. There we go. So purple is the function of the amount of money in Jenny's account based on x and interest rate, and then here is a specific interest rate we want to find the intersection of. And if you look at our graph, these values do not show where these things intersect. So we need to change that. And to change that, we're going to go to the wrench. And actually, I can't move that. So you're just going to, my face is going to block some of this. The x values are the interest rate. And now that's technically 1 plus the interest rate. So 0 is plenty small enough. And now 1.0 is a 0 interest rate, and 2 would represent a 100% interest rate. So the 1 plus 100% is 2. So 2 is going to be plenty high enough where it puts 1 point something in the middle of our screen so that we could see that intersection point. And now my y value that I'm playing with here on the bottom, Jenny's never going to have $0 in her account until she withdraws the money. So my lowest value is going to be 0. And then my highest value, I'm going to go up to $2,000. And that should show, and does show, the intersection nicely. If it didn't, I could always make the 2,000 smaller or bigger depending on what was happening. But I'm going to leave it at 2,000. And sure enough, in the middle of my screen here is the intersection point. That intersection point gives me the x value of 1.03, representing the 3% interest rate. And then that y value on the screen tells me the amount of money in the account at that interest rate. So the answer to number 2 is this y value, $950.32. So y is equal to $950.32. That is the answer to number 2. So we're going to go on to number 3, and of course if you had a different interest rate, you would just change your x value and still find your y value. If your amount of money was different for number 1, then your equation is going to be different and look a little different depending on the length of time it was in the bank account for and how much money was deposited each time. So now number 3 again might change. This type of problem might change for you depending on how much money you want to save. So keeping in mind that y values represent the amount of money in the account, this question asks for the interest rate. What interest rate does Jenny need if she wants to save $1,100? So this time we're doing the opposite. For number 3, they're giving me the y value of $1,100. And now they want me to find, I don't like the way that looks. They give me the y value of $1,100. And they want me to find the interest rate. So we're going to graph this now instead of the x value we had before and still look at the intersection, except now we're going to be pulling the x value out. That's what we're looking for. So back to Desmos down here. And now instead of x equals 1.03, we change it to y equals the $1,100, $1,100, and there it is graphed, and that intersection point is of course what we're looking for. We want the interest rate, so we take the x value, 1.0705. So x is equal to 1.0705. Now with this particular problem, this 1 is always going to be there. It's this piece that represents the percent. So the decimal 0.0705 is what I need to change to a percentage to find the interest rate. So to do that, I move the decimal 2 times, 2 places to the right, and I get my answer of 7.05%. This is the interest rate Jenny would need if she wants that $1,100 for her down payment on her car. So questions number 2 and 3 sort of mirror images of each other. Question 2 gave me the interest rate and I was finding the dollar amount. Question 3 gives me the dollar amount and I'm finding the interest rate. If you have any questions on this, leave a comment below. If you've got a specific problem you're working on that you want to see a video on, leave me a comment. Have a great day.